C# history. This is part 1 of C# history. C# 7.0 introduced stack-alloc, fixed statement, and access fixed fields without pinning, among other language enhancements. Stack-alloc is a keyword in C# used to allocate a block of memory on the stack instead of the heap. It's typically used with span less than t greater than or unsafe code for high-performance scenarios like temporary arrays that avoid garbage collection. The fixed statement in C# is used to pin an object in memory, preventing the garbage collector, GC, from moving it. This is crucial when working with unsafe code, such as pointers, where the memory address must stay constant. In C# 7.3, you can safely access fields of fixed-size buffers inside unsafe structs without pinning the entire struct. This is especially useful in interop and systems programming. In C# 7.3, you can reassign ref local variables, meaning you can point the same ref variable to a different storage location after it's been declared. This is useful when you want to work directly with memory locations. You want to switch which variable or array element you're modifying via a single reference. A read-only struct in C# is a value type where all instance fields are guaranteed to be read-only. This means you cannot modify its fields after it's constructed. It's immutable by design. The compiler ensures that no accidental modifications happen to its fields. Introduced in C# 7.2, it improves performance and safety, especially when passing structs by reference, in parameters. In C#, ref read-only is a modifier that allows you to pass a value type by reference, but in a read-only way. This means the method, or property, that receives the variable can read from the reference but cannot modify the value. Efficiency. Avoids copying large value types, like structs. Safety. Prevents accidental modifications. In C#, a ref struct is a special kind of struct that is stack allocated and cannot be boxed, captured by closures, or stored in heap-based variables like fields of a class. When we use it, efficiency forces stack allocation, avoiding heap allocation and garbage collection. Safety prevents you from accidentally storing references to stack data on the heap. In C#, named arguments allow you to specify argument names when calling a method. Normally, if you use a named argument, all arguments after it must also be named. But starting with C# 7.2, you can use non-trailing named arguments, meaning you can mix named and positional arguments, even if the named argument is not last. In C#, underscores, _t can be used inside numeric literals to make numbers more readable. This was introduced in C# 7.0. However, leading underscores, i.e., underscores at the start of a numeric literal, are not allowed and will cause a compiler error. The private protected allows access within the containing class and by derived classes that are in the same assembly. It was introduced in C# 7.2. It restricts access outside the assembly. A conditional ref expression in C# lets you return a reference to one of two variables based on a condition, without copying the values. Introduced in C# 7.2, it's the ref version of the ternary operator. C# 8.0 was launched in September 2019 with Visual Studio 2019 and .NET Core 3.0. C# 8.0 brought significant language improvements, including nullable reference types, ranges, and default interface methods. In C#, read-only members are instance members, like methods or properties, that are guaranteed not to modify the state of a read-only struct. This was introduced in C# 8.0 to improve safety and performance. You use the read-only keyword to tell the compiler that this method will not modify any fields of the struct. Default interface methods, DIMs, allow you to provide a default implementation for a method inside an interface. It was introduced in C# 8.0. Before C# 8.0 we cannot have body of the method, we just have abstract method which we must be implemented in inherit class, but after C# 8.0 we may have abstract metnod as well as we can have default method with implementation. A using declaration in C# is a simplified way to ensure that resources, like files, streams, or database connections, are disposed automatically. Introduced in C# 8.0, it replaces the older using statement block with a cleaner declaration-only style. The resource is automatically disposed at the end of the scope it's declared in. A static local function in C# is a local method declared inside another method using the static keyword. Introduced in C# 8.0, it cannot access local variables or instance members from the outer method, only what you explicitly pass in. This makes it safer and faster, because there's no hidden state or closure allocation. A disposable ref struct is a ref struct that implements the iDisposable pattern to allow scoped and stack-only cleanup. It combines the benefits of stack-only allocation, from ref struct, with deterministic disposal, like using. Introduced in C# 8.0, it's often used for high-performance and low-allocation scenarios like span less than t greater than or custom buffers. Nullable reference types let you explicitly indicate whether a reference can be null, helping you avoid null reference exception. Introduced in C# 8.0, they enable the compiler to warn you at compile time when you might be using null incorrectly. It's a compiler feature, no runtime behavior changes. Asynchronous streams in C# allow you to iterate over data asynchronously using a wait for each. They're built with the iasync enumerable less than t greater than interface and the yield return pattern, and were introduced in C# 8.0. Useful for reading data from slow sources like files, databases, or APIs without blocking the main thread. Indices and ranges in C# allow you to access elements from the end of a collection, or extract slices, x, y, using concise syntax. Introduced in C# 8.0, they simplify working with arrays, spans, and other indexable types. The null coalescing assignment operator, smiley face, in C# assigns a value only if the variable is null. It was introduced in C# 8.0 and simplifies checking for null before assignment. It's a shorthand for, if x equals null, x equals value. Unmanaged constructed types in C# refer to generic types that are considered unmanaged when all their type arguments are unmanaged. An unmanaged type is a type that doesn't contain any references and can be used in low-level operations like unsafe code or interop. C# 7.3 introduced support for using generic types with unmanaged constraints, even when they are constructed types, e.g., struct point less than float greater than. In C# 8.0, you can now use stack alloc directly inside expressions, such as method arguments, constructors, and return statements. This was not allowed in earlier versions. This feature is called stack alloc in nested expressions, and it allows for more concise and flexible usage of stack allocated memory. An interpolated verbatim string in C# combines the string interpolation, $, to insert variables, expressions into the string. Verbatim string, to preserve whitespace, line breaks, and escape sequences like backslashes. C# 9.0 was launched in November 2020 with Visual Studio 2019 and .NET 5.0. Some important features of C# 9.0 are discussed in the next slides. In C#, record structs are a value-type version of records. It was introduced in C# 10. They combine the immutability and value-based equality of record types with the performance characteristics of structs. Init-only setters, introduced in C# 9.0, allow properties to be set only during object initialization, not after. They support immutability, which mean that an object's state cannot be changed after it is created. All fields or properties are typically read-only or have init accessors, ensuring the object remains constant throughout its lifetime. This makes code cleaner and safer. Top-level statements, introduced in C# 9.0, allow you to write C# programs without explicitly defining a main method or a class. This makes the code simpler and cleaner, great for small apps, scripts, and learning. In C#, performance and interop refers to writing high-performance code and interfacing with unmanaged, native code, like C, C++ libraries, through interoperability, interop, features. Native-sized integers in C# are special integer types that automatically match the bit size of the platform, 32-bit or 64-bit. They are useful for interoperability and performance, especially when working with pointers or low-level code. Function pointers in C#, introduced in C# 9.0, allow you to call functions by their memory address, similar to C, C++, for high-performance or interop scenarios. They're only available in unsafe code and are useful when calling native methods or optimizing code that needs direct invocation without delegate overhead. In C#, the local init flag tells the JIT compiler to 0 initialize all local variables. This ensures safety, but it may slightly impact performance in performance-critical scenarios. Module initializers are methods that run automatically when a .NET assembly module is loaded, before any other code executes, including main. They're useful for low-level setup tasks like initializing static data shared across assemblies, setting up native dependencies or logging, running configuration before anything else. It was introduced in C# 9.0 and .NET 5.0+. In C# 9.0, partial methods were significantly enhanced. Previously, they had many limitations, like previous limitations before C# 9.0. Must return void, cannot have access modifiers, no out parameters, only callable within the same partial class. Fit and finish features in C# refer to small language improvements that make the language more consistent, readable, and developer-friendly. These are not major features, but refinements added to polish the language, introduced mostly in C# 9.0. Target-typed new expressions, introduced in C# 9.0, allow you to create objects without repeating the type name when the compiler can infer it from the context. Static anonymous functions, introduced in C# 9.0, are static versions of lambda expressions. They don't capture variables from the enclosing scope, making them target-typed conditional expressions, introduced in C# 9.0, allow the result of the ternary operator to infer its type from the context, even when the two branches are different types that can be converted to a common target type. Covariant return types, introduced in C# 9.0, allow an overridden method in a derived class to return a more specific, derived, type than the method it overrides in the base class. Lambda discard parameters, introduced in C# 9.0, let you ignore unused parameters in lambda expressions using the __. In C# 9.0, you can apply attributes to local functions defined inside a method. This is useful for things like debugging, debugger hidden, optimization hints, custom tooling or diagnostics. Thank you. End of part 2 of C# history.